I picked the topic attention and memory just briefly because they're such common complaints. Often attention is confused for memory, and the most common symptom, cognitive symptom, is my memory isn't working. Well, memory has to be distinguished from attention. For memory systems, some people use analogies such as walking into a large house and storing information in every single room. Well, imagine that you owned a very large house, or you were walking into a mansion, and there was a big hallway that you had to traverse from the outside of the house all the way down the hallway before you got into, say, the living room or the kitchen. That hallway that you traverse would be like attention. Attention is a process that directs brain function towards every one of those rooms. What occurs in the room is memory. So information first has to be stored, then it has to be retrieved. And the storage process is an overlap between attention, working memory, and then retrieval. In order to pay attention, you could think of driving a car. You have to select the in front of you, if the lights change in color, you have to select in your focus what you're focusing on, and you have to maintain that. That's called vigilance. And then you have to shift your attention. The test that I showed you was a shifting attention test. You have to shift back and forth according to rules. Attention can be thought of as a bottom-up or top-down system. Meaning, top-down meaning you use cognitive strategies and you tell yourself, I'm going to focus on this, I'm going to focus on this. Bottom-up means that it's hormonal-driven, or it's neurotransmitter-driven, or it's electrically driven, and you don't have much choice over it. The most common complaint with attention is, I don't have enough of it, or I'm easily overwhelmed and I get distracted. Distracted to what? Well, the spoken word, the written word. I used to be a good reader, and now when I read a sentence, I don't seem to have the power to go beyond a few lines. I have to go back. Or I can only read when it's very quiet. I don't seem to have the mental stamina. Or it seems to be too noisy. I'm easily distracted out there. So external influences or internal capabilities seem to be disrupted. So attention emerges as a function. It's not like a location for attention. Attention is a function that comes from different brain networks. It involves a relay with the limbic system and the frontal cortex. And attention can be thought of as involving, if we think about visual attention, a where system and a what system. So here's a schematic from Dr. Heilman's book. The where system is thought to be the dorsal part going from the parietal lobe forward. And if you were to look at me and see where I am, or look to your right or your left, that where would be where you would direct your visual attention. But if you had to have a name for something like a door or a lamp or a light, that would be a what system, and that's stored in the temporal region. Those systems can be selectively disrupted. What happens with memory? Well, after attention comes memory. Memory is the glue that holds our experiences together. And there's memory for different functions. We have memory for our behaviors and our thoughts. We have an autobiographical memory. We might remember an incident from when we gave our mother a rose, or when we hit a baseball over a fence. And we have a declarative memory, a memory that's stored for information. What's the capital of Spain? Portugal. Where is Dubai? Or how to draw a trapezoid. And those memory functions can be selectively interrupted. Most of the memory systems are held deeper in the brain, in the medial temporal lobes, in the limbic system. I wrote here acetylcholine because I frequently use a medicine that's used for Alzheimer's disease that increases the signal for acetylcholine. Acetylcholine is a neurotransmitter that's involved with processing speed and access to memory. I wrote here glutamine because glutamine is involved as a chemical that disrupts inside the hippocampus where memory is stored. So now we talked enough about brain. That's probably enough to just put you on the edge there without falling asleep. How does a person evaluate a mild traumatic brain injury? We know the person's Glasgow-Coma scale was 15, 14, or 13. They altered consciousness. They complained of a headache. They don't feel right. Well, they're usually evaluated initially with a CT, but we want to look at the brain function and at the brain structure. So if we take an EEG, this is a picture, it's a snapshot of an EEG which records electrical signals. Frequently that's done to see whether or not the complaint of memory or attention is because of a seizure. Post-traumatic epilepsy can occur 10 years later. It's more common in blast injuries than in falls and accidents. And there's a way to look at that EEG with a mathematical formula through a database to determine within that EEG where the slow rhythms are and where the fast rhythms are. So in the upper right part of your slide, that's a key. And what it says is, where it's yellow, that's 2 standard deviations more than where it's magenta or blue. And across the top of the screen, there are words. It says delta, theta, alpha, beta. That refers to a grouping of cycles per second of brain waves. Frequently what happens when those axons are twisted, when those brain networks are altered, the processing speed in the brain slows down, sort of like running a track. You run around the track when you're 18 and you run around it when you're 70, your speed is slower. That's captured on this QEEG by seeing more of that delta signal across the front of the brain. Here we compare to a normative database, and you see on your left there, across right beneath the nose there, it's yellow, and then there's a rim beneath there that's red. This is a quantitative analysis of that EEG. It's readily available. There's many people across Chicago that do this. And what it's displaying is that there are more slow waves. The waves are at 2 to 4 hertz or 2 to 4 cycles per second. There are more of them in the front of the brain than there should be. Or the front part is too interconnected. That's called coherence.